Okay, so we are going to get the conclusion on this little part about rates of change. And so the overall ideas here are looking at the average rate of change. Okay, average rate of change versus the instantaneous rate of change. Instantaneous. There we go. It does take a while to get instantaneous. Okay, that looks really funny, but that is actually how you spell instantaneous. Okay, it's got two tans right in the middle of it. All right, so average rate of change versus instantaneous rate of change. Okay, so average rate of change is kind of a handful to write. So sometimes we'll abbreviate this AROC. Okay. And an average rate of change in general is just like what we were looking at here with our average speed. Speed is a rate of change. So we're going to use the same type of formula for an average rate of change in general. You can calculate an average rate of change by taking the function value at time t2 minus the function value at time t1, and then dividing by the change in time, t2 minus t1. There we go. Okay, so this is a good one to know, average rate of change. All right. Now, this is opposed to the instantaneous rate of change. All right. And for right now, the best we can do to calculate an instantaneous rate of change is what we were doing in the previous problem, where we would just estimate the instantaneous rate of change. In that previous problem, we were estimating the instantaneous speed of our object. And yes, that really is the best we can do for now. Later on in the class, we're going to have more solid ways of calculating an instantaneous rate of change. But for right now, we're just going to say that this is the value that is approached as T2 gets very, very close to T1. So bringing in those times closer together, getting a very, very small time interval. Remember this picture up here of our number line or our time line? By bringing in that time interval and making it smaller and smaller, we narrow in on the single point that we actually want. So that is how right now we are estimating an instantaneous rate of change. We'll do more with this idea and we'll see what this looks like graphically in the next video.